So hello everyone. So as I said, we are working on TensorFlow. So I decided to make a video about what exactly are neural networks and what are the fundamentals to actually code a machine learning algorithm. So first of all, we will have to understand that what are neural networks and how does an algorithm works and communicate with other nodes in the neural network. So basically, starting with neural networks, I would like to say what are nodes. So uh, let me start something here. Uh, Wait a minute. Before that, I would like to show the book which I used as a reference for understanding machine learning and how to perform machine learning algorithms using Python specifically, because we all know that Python is very efficient when we are working with machine learning algorithms and implementing those. So this is the book. I will also uh, give the link in the description about this book, and you can all buy this book from Amazon and any online store you wish to buy from. And this book has a lot of things to focus on. Basically, in this book has the introduction to Python and what exactly is Python, how we can use Python for initializing the stuff or the implementation of different kind of algorithms. And it also has a deep explanation of pandas and scikit-learn, some initial libraries or we can say dependencies we need to focus on when we are working with machine learning. Uh, so this book is pretty good. I would really recommend it. You should all read this book before diving into the actual coding part, we can say. And now that my internet is live, so let me just show you what exactly I was talking about. Just move the camera a bit. So my internet is really slow right now, but I will try my best to keep up. So basically, I have this presentation here, which will guide you through the process, and we can say the way of understanding neural networks. So here you can see what exactly are neural networks. Here you can see the nodes, the green node, the blue nodes. Here is these are known as the levels. Uh, the first one is the green nodes, which are two nodes in the neural network, and they are the first level, you can say. The second one, which is also known as the hidden layer. Sometimes we uh, use hidden layers to make a algorithm more complex and increase the accuracy of the algorithm to predict something depending on the specific task we want the algorithm to work on. And this is the hidden layer, I guess. And next one is the output layer, which is responsible for generating an output. And the green one here is just an input layer. Uh, so this is the structure of the neural network. Now I want you to understand what exactly is these nodes connect when they are connecting. So how they perform their operations, right? So I have this link in this PPTs, which I would like to go and open on another tab. And when I do that, so here you can look at the the structure here. You see, this is not the actual structure how the neural networks are, but I found this image on the internet, so I thought why not just take this image as a reference and also create my own. You can see the structure down here. You can see here. Uh, this is the connections, how the neural networks communicate with each other. I also found this circle thing which was blinking, and I thought that this is, we can say, mimicking the activities of neural networks. So these neural networks are connected to each other. Every node is connected to every other node in the other layer. We can say the layer, second layer, and this is the input layer, which basically has uh, four nodes, and second layer has four nodes which are connected to each other equally. We can say the first node is connected to all the four nodes from the second layer, and the second layer is also connected to the first layer, first layers of nodes, and whatever the nodes are there in the first layer. So I have this note here written that the node one details it has different implementation of the code, but communicates with the node 2 and concurrently communicates with other node 3, node 4, and node 5 here. Okay, so this is just an what do you say? It's a structure how neural networks communicate with each other. And this is here the output layer which has two nodes which calculates everything, and after that it is responsible for generating an output which we are expecting from it. So this is just a basic understanding of what neural networks are and how they communicate with each other. Basically why they are called as neural network, because if there is node, let me show you a demonstration here, which this example I used in my presentation when I was explaining convolutional neural networks in my college. So let's assume these are two nodes. These are buds basically, and these are two nodes. This one node has an different code or different logic implemented in it, and the other node also has a different logic and different kind of code we can say, which responds to this code, and this code responds to that code. So we can say they are communicating with each other. So uh, this activity actually mimics the working of our neural networks in our brain. That is why we call them neural networks. This piece here, this node here is connected to this node, and they communicate with each other to perform several tasks, or we can say perform a specific task given to it. So we can say that this is the reason they are called as neural networks, because they mimic the operation or mimic the process of actual neural networks in our brain. So, some of you may ask, why do we need neural networks? We can just implement an algorithm like this, and why not just implement a simple plain, you can say 1,000 lines, or we can say like 10,000 lines of algorithm to implement that. But the idea here is that the nodes which are responsible to generate an output are very different, and it can sometimes get complex when we are working with a large model. And the more the nodes are there in the neural network, we can say, or the layers are there in the neural network, the more complex it becomes and the more accurate the prediction we are expecting from that algorithm. So this is the basic understanding and basic logic behind the neural networks. Here I also wrote a note here, a structure of neurons in neural networks. This is just a structure which I wanted to show. They are just like neurons in our brain, but are neurons which are coded to perform some specific task. And the image here is not the exact image of what neural networks look like, but looking at this image, you can understand that what neurons look like, and you can interpret that structure to develop your own neural network. I I will also put a link in the description about how to develop your own neural network and how to develop your own structure from scratch. I'll give the link in the description. There is this guy known as what is his name? Some teenager with really good understanding of neural networks. He created his own neural network from scratch by hard coding it, and I think you guys should all check it out, because it is really important to understand and clear our concepts. If we don't do that, it is really hard to implement any kind of project when we are working with machine learning. So that is it. It is just a basic neural networks, and what I want to say that is this is just an basic thing. What actually happens inside a machine learning algorithm. But the thing is that when you want to when you want to create a project where you have to implement a image-based processing, or we can say image-based predictions, or if you want to generate your own image, then there are different kind of neural networks, we can say. There are, for example, RNN, recurrent neural networks for working on language models, we can say large models, text-based models. Then there we use recurrent neural networks. And for image based and image processing, we use CNNs, the convolutional neural network. There are different kind of neural networks. In that, the RCNN refers to the region based convolutional neural networks, and there are also two parts in it, the fast one and the faster one. um, if you want a detailed video about it, please let me know in the comments. And this is just an idea about what neural networks are. So I thought at the initial stage that I was really confused how this everything works and how exactly a machine learns, because it is really hard to comprehend someone who is just going to learn something new, and if they don't understand what exactly is happening, how a machine is able to understand some things, and we can say interpret human language and all that kind of stuff, then we have to understand what exactly is happening inside the code. We can say what is exactly happening uh, in the code, or what is the logic there that makes the machine understand what is the human interpretation. That is it. I guess uh, that will be it. And here is the image of supervised learning and unsupervised learning. So here is an example. When there is a machine, the machine is fed with the images of cats and some different kind of faces of cats, we can say, and the machine has given some time, and there are some algorithms, some parameters to check for the machine, and then the machine analyzes it, works on the data, and there are different kind of parameters to it, and after that, the machine is able to understand it with depending upon how many layers are there implemented in the code, or we can say how complex is the code, uh, and how balanced or how clean is the data, so that the machine learning algorithm can actually understand from it. And after that, taking care of null and missing values. It is not the case with the image-based processing, I guess. It is the case with the text-based processing, from whatever the knowledge I have till now. So it is from the text base, and when we are working with some basic level projects where we have to predict some churn values, you can say, which I uploaded a video about before this series. The first video of this series is all about churn, and I haven't told anything in detail, but you guys get the idea what is churn here. I also explained that churn is nothing but the specific company has some customers and they stopped using the product, and that is the value we say churn. If a person has churn, means if the churn value is yes or one, we can say the person has stopped using their product, and if it is zero, the person hasn't stopped using their product. So that is it. And here the machine understands the cat, and whenever there is something wrong with the image, we can say when we are testing the algorithm, after the when we divide the test and training data, and when we give that testing data to the machine, it is able to understand which image is of cat and which is not of cat. So it will just tell you this, these are the images I found which are related to cat, and these are the images I found which are not related to cat, you can say. This is the image where there are two images fed to the system with the dog and the one with the cat. So machine here can understand that there is only two images of cat and the other are dogs. So it is really able to understand it, and this process is known as supervised learning. And what is unsupervised learning? Unsupervised learning is something which the data is given to the machine, and the machine just creates small groups with which have similarities within them, and they just divide it, and we can say if there are six values: dog, cat, dog, cat, dog, cat, like that. And if we tell the machine to differentiate between that using an unsupervised machine learning works, and the machine is able to divide them into two groups which have similar properties, and this is done using the clustering process and anomaly detection. Uh, in the supervised learning, the algorithm is able to classify and sort items into different kind of categories, whatever there are in the input we can see in the data, and there's also some regression identifying real values and all that kind of stuff. I'll also tell about these methods, or we can say types of uh, optimizers, or we can say the algorithms which are used in the machine learning while classifying, using regression, what is clustering, and all that kind of stuff. I'll tell you one by one after we understand what is the basic idea how machine learns and all that. This video is all about that, what exactly happens in the machine, and I guess that is pretty much it. And so I guess that is all. The other thing that what are the components of or the requirements of a machine learning for a machine to learn something specific. First of all, the important thing is that the data should be clean and balanced. It should be balanced because if the data is not balanced, it can predict some values which are not appropriate, or we can say which is just not expected for the machine to predict. That is why we need specific data, and the data should be clean and balanced. The second thing is that the data should be clean and balanced, of course. And the third thing is that the algorithm that fits perfectly or it is close to perfect, we can say. The algorithm which we are using should be able to comprehend the data and work with it. Um, uh, Something like that. So algorithm is really important because if the algorithm we are implementing is efficiently working with an CNN kind of thing, and the operation we are performing is text based, then it is not really able to the machine to understand it. We can say sometimes that happens with me. Initially, when I was implementing this kind of algorithms, I uh, mistakenly used a CNN network, neural network for implementing a text-based data at the initial. But after some research and after knowing some things, I understood that the algorithm really important part of the code, which should be really perfect for the complete data, and it should really be able to understand with all the data which it has been fed with, and the complexity and the number of nodes in the neural network is really important because the more the neural network more the nodes in the neural network, the more the code becomes complex, or we can say the algorithm becomes complex, and the more it is able to give you the best accuracy out of it. The fourth thing is that when we are working with data, we have to take care of the null values, or we can say the missing values from the data. We have to sort that all out before feeding it to the machine, so that machine can generate a good accuracy. Uh, this also happened with me when I was working on the churn data a few days back, we can say a week ago, and at that time I was not taking uh, the data which I had was having some missing values, and that is why what happened, the algorithm was not able to give me some good accuracy. Initially it was about 0.47 point something, 0.4747 something kind of accuracy, and there was like 0.4569 loss factor. So when we talk about taking care of missing values, it is really important part of data when we are going to feed that data to the machine. The fifth thing is that use the appropriate optimizers to reduce loss and increase accuracy. Optimizers, we are going to talk about it. The optimizer I used in my code previously was the Atom, and the sixth thing is that twisting and tuning parameters to explore different outcomes. When we are working with a machine learning algorithms, we have to actually twist and turn every parameter so that we can get the appropriate outcome. Uh, yeah, that is all about the, we can say, the back propagating kind of thing, which is similar to back propagating, but propagating is a really different algorithm which is used to explore new outcomes, we can say, by turning the parameters or twisting the parameters in the machine so that we can create a um, algorithm which produces a very less loss and gives us the best accuracy out of it. The seventh thing is that the testing and playing around with the machine learning algorithm. After we are done with the complete process, and after we are done with the implementing all the kind of things, taking care of missing values and using appropriate optimizers, we should be able to test the data by the testing data, using the testing data. and we should play around with the model so that we can understand it and try to figure out how we can increase the accuracy of the machine learning algorithm. uh, that is all to it, bro. That is what I wanted to tell in this video. This video is becoming too big for now because it is 20 minutes, and I think that is all I wanted to share here. Thank you for listening and have a good day. Uh, have a good night actually, because I am recording this video in the evening, and I want you guys to understand, and please let me know if you have some doubts, or we can say please let me know if I'm wrong somewhere, because while I'm making these videos I myself am learning these things and trying to implement it myself, and if I face some problem while doing it, I'll surely make a video about it. And if I'm wrong somewhere, please let me know, because if you are going in the wrong direction, if we are going in the wrong direction, it doesn't really matter how long we go, how far we go, because the direction is really wrong. So if someone is actually working on this kind of models, and if you know something better than me, please let me know in the comments, because it is really important part for learning. And that is it, guys. Thanks a lot for your time and listening to me. uh, I guess that is all. Thank you and have a good night.